Here we are discussing the previous year questions on the net examination physical science part, and this is from December 2023, where we have a matrix 3 cross 3 e to the power 3 cross 3 matrix M, and also we have e raised to the power m theta to be equal to that which is given in terms of cosine and sine. Now we need to find m, and we have the options available to us. I've done the solution over here. We'll just go through it. Now let's consider taking out the eigenvalues, and for that we have e to the power m theta, the matrix, minus lambda times of the identity, where we end up with the eigenvalue. You can go through the entire process, and we have obtained the eigenvalue that is over here. These are the eigenvalues. Now e to the power m theta in this case will be the determinant. If you take it, that must be equal to 1, which is e to the power 0, and here that means the eigenvalues of m, they have to be 0. Now, in order to get the eigenvalues of m to be equal to 0, we first consider the trace of m. And the trace of m, as you can see in options C and D, the trace is not being equal to 0. So they have to be neglected. They are not the correct options to consider. So now we move back to the case of the option A and B. Now, if we obtain the eigenvalues of lambda, eigenvalues of these matrices, then we have lambda to be equal to 0, 1, and minus 1. And then we have lambda to be equal to plus I, minus I, and 0 in the second option B. Now, when you put these values, these are the values of m, of course, and when you put these values of m, you must get the eigenvalues that you had obtained for e to the power m theta, which is over here. Now, obviously, when you put these values, they are not being equal to the ones that we had obtained over here at the top. So these are matching with this eigenvalue. So option B will be our correct option in this case. Now, in the next question, we have the beta function defined as beta xy integrated from 0 to 1, t raised to the power x minus 1, 1 minus t raised to the power y minus 1. And in this case, we have to see whether this beta x comma y plus 1 and beta x plus 1 comma y will be equal to, and we have the options, the 4 of the options that are available. So we have to check that which of those options are matching. To save time, so this is what we have to add, and we have to check from the 4 options that are available. Now, in order to save time, I have just added them up. If we have a beta x comma y plus 1, so instead of just y, we have y plus 1, which means the power term over here, which was y minus 1 right at the top, as you can see, that becomes for y plus 1, that becomes equal to y, which is what I have done over here. And in the next option, if we have a beta x plus 1, so if we put x to the power x minus 1, instead of x we put x plus 1, so in the next case this one becomes t raised to the power x. And so we have the left hand side terms, and we are going to add them up in order to get this. So we add them up. The left hand side is as per the requirement, and then the right hand side now, well, t to the power x minus 1 and t1 minus t to the power y minus 1, they are the common terms in each of them. So what is left is, because you have taken these two as the common terms, so in the first case, 1 minus t raised to the power y minus of y minus 1, because this factor has been taken out as the common term. So this 1 minus t remains from the first term. And in the second case, as you take t to the power x minus 1 as the common term, so only a single t remains and we have a t over there. Now 1 minus t plus t is obviously equal to 1. So all that you're left with is this, and this is nothing but the beta function that we have defined over here right at the top. So the answer will be option D. So that's the way to try it. You can try it in any other way you like, in case uh, you have any shortcuts, but this is the ultimate shortcut, I think. So I've tried it this way. The next bit, we have the given function fz to be equal to that which has been provided over here, and you just need to find the branch line, right? And well, let's look at the function first of all. If I can try the solution over here, we have fz. Now if you look at it, then the bottom one in the denominator, you have actually z plus 1 squared, and at the top, if you factorize that thing, you'll get z minus 3 and z minus 2. Now z plus 1 obviously doesn't really create any problem. That goes outside the square root. That is just z plus 1. But what about the case with z minus 3 and z minus 2? Well, if z lies within that value, you can actually have 2 minus z and 3 minus z as well. So because both will be negative of negative, and that will cancel out. So z has to remain within that 2 and 3 range, and that will be your branch line. So the option C over here is the correct option. Okay, now we move over to the section or the part C of the question set from 2023 December. And we have a function fz which is given as 1 over the product of z plus 1 z plus 3, and it is defined in the complex plane. We have to find the coefficient of a z minus z naught squared term, and of the Lorentz series expansion of fz about z0 is equal to 1. And we have the options that have been provided to us. Let's check. Now, as far as the expansion is concerned, we have fz as per the Laurent series expansion. We have fz to be equal to cn z minus z naught to the power n, and cn is equal to, obviously, as we can see over there, is f omega d omega omega minus z naught raised to the power n plus 1 integrated over the closed area, and that multiplied to 1 over 2 pi I. Now for n is equal to, we will however not need that. We'll find a more easier way. So for n is equal to 2, because we have z minus z naught to the power 2, we have to find that coefficient. So and we have been provided z naught to be equal to 1. So we have z minus z naught to be equal to z minus 1. Let us assume that is t. So here we have z is equal to t plus 1. Now because z is equal to t plus 1, so that function now changes to, now the first term was z plus 1, so z is equal to t plus 1, so that becomes t plus 2. And next term was z plus 3, but z is equal to t plus 1, so this is now t plus 1 plus 3, which is equal to t plus 4. And what we can do is we can take the 2 to be common from the first term and 4 from the second term. What we are left with is this, that is 2 times of 4 is 8, and because they have been taken as common, they are divided, they get divided to that t, and we take the inverse of it because they are in the denominator, so we take the inverse power and we expand it binomially. So from binomial expansion we have this. Now we have to focus on the t squared term, because t squared is z minus 1 squared, whose coefficient is to be determined. So multiplying only to find the t squared term, we have these three t squared terms. So we take the t squared out of it, and what we are left with is 1 plus 2 plus 4, with the LCM being 16. 16 multiplied to 8 is 128. 1 plus 2 plus 4 is 7. So this is 7 over 128, which is the option B, which is the correct option in this case. In the next bit, we have the case of data given to us. For every value of x, you have a value of y, which has been given in the form of that table. And using Lagrange's method of interpolation, you have to find y of 4. That is, for x is equal to 4, you have to find y, and that will be closest to one of those options that has been provided. Now, y of 4, because you are taking x to be equal to 4, and let's assume that x1, x2 and x0 are the values that have been provided to us. That is, for x0 is equal to 1, you have y of x0 to be equal to 4. Y of x1 will be equal to 28, and y of x2 will be equal to 92. These have been provided. So we have the formula over here. First case, you have x, which is to be determined, the x which has been provided to be whose value y you have to obtain. You keep it as x as of now, and we take in the denominator we take x1 terms, and then we have x0, and we have x2. You can take it any other way you like. And here you have y1, y0, and y2. So correspondingly, you take those values, and if you plug in the value of x to be equal to 4, in that case you end up with this value 55, which is the second option. I've done it in my rough work. You can check it for yourself and observe that this is the method to do it. So these were some of the questions from for mathematical physics from for December 2023, the PYQs. There are many more questions on mathematical physics and other subjects as well, other topics, um, other units of physical science for the net exam. We'll be doing them as and when we uh, can do it as per the time permits. I'll try and finish most of the questions in the last 5 years, uh, especially starting from 2019 onwards. I'm trying those questions and I'll be uploading them. You can see and try for yourself in your prep up for the upcoming exam. Till then, thank you for watching.